Alrighty, guys. Back. 19. We got speed. We got time. We got distance. Okay. If it takes 8 seconds. So if time is 8 seconds, then position 0 is 32. Time is 1 second, then what? Think about this. First off, I think it's 32. By 8? 4 per second. Moving 4 spots per second. So you're starting at 64 after move time of 16 seconds. Yeah, because let me guess. 4, 36. Here is 64, of course. So it would be 0.4 and 0. Fantastic. Pardon, Batista. Were you here all night? Hmm? Oh, looks like it. Batista, you need sleep. Working on an important update. You can wait. We have plenty of tools to continue our translation already. This one's important. We'll be done soon. Alright, so what's the speed if after 3 seconds we've moved 24 spaces? Okay, I mean, that should be pretty easy. So 24 spaces divided by 3 seconds. Okay, if I could type correctly. So the speed is 8 length second. Okay. That beautiful confetti. Alright, so we're starting from 0. After 14 seconds, we're at the 2 variables. Fix that, the old dictionary again. Yeah, let's try that. Okay. If time is 66 seconds, then it wouldn't have moved, right? There's no movement because the point is at the exact same thing. What? Bro? Think how many times has it moved? Just 66. Oh. Move time. Move time. Hmm. Think. Got 14 seconds. Move. So they're saying we're starting at 14, we end at 66? Is that the question? It would be 52? 52 length? Or just 52 seconds. Okay. Okay, that kind of makes sense. Whoa! The confetti has colors. Whoa, huh? When did this happen? Alan, the confetti, it's colored now. Glad you like it. Just one moment. Don't tell me this is what you sacrificed your sleep for, Batista. Don't tell me this was your big update. It is. Come on, Carrie, look at it. This is great. Batista, this is not important. While a good night's sleep is important for both your health and general well-being. This was important. I can't wait for the next transmission if it means more colored confetti. Batista, I understand now. Come on, team. What are y'all jabbering about? We gotta figure out how to respond. There you go. The spirit-lifting rainbow confetti. So, what's the speed if we're starting at 1 and 2? Alright, let me think about this. Start. End. Starting at 1, 2. Ending at 10, 2. So we're moving. Move 9 spaces in 18 seconds. Right? 2 length seconds. What am I missing? We moved to 9 in 18 seconds. Two length seconds. I'm trying to think here. Time difference is 18 seconds. Am I thinking of it backwards? Is it really like, is it really 9 over 18? So what was that, 0.5? Maybe. I was thinking of it backwards. Because it's distance over time. Okay. I gotta keep that in mind. It's distance over time. In fact, a dictionary speed. Distance over time. So we're starting at 0 and 0, 0. So we move a total of 18 spaces in 2.25 seconds. So 18 divided by 2.5. Uh, 8 length seconds. That makes sense. Okay. Look at that confetti. Alright, new symbol. Something. Something is speed. Test. Speed is greater than something. False. Something greater than speed. Variables. It's true. Don't quite understand that one yet, but let's see what else they give us. Signal. Move speed equals something. What equals? Got another one here. Oh, and it can't be question mark either. Alright, so let's call this A. B. And we have an idea. I think I know what A represents. The fastest speed in the universe, the speed of light. Okay. Why do we think A is the speed of light? Length times time. Why do we think that? And I guess I'll put it in. A is light speed. Light speed, truly universal constant. Across the entire universe, it's baked into the fabric of the universe. Truly universal. Another point of reference between humanity and the aliens has presented itself. Our universe of discussion continues to expand. So B is B light year then, if it's length? Light. Or light second. Maybe. Light second equals what? Count one. No. Is it length? Okay. I kind of understand. Alright, so something. One something equals one light speed divided by one light second. I think I need astronomy for this one. Speed of light. Okay. Speed of light divided by this mystery number. 3427772. One something, one light second divided by blah blah blah. 2 light seconds. What? 2 question marks? No, okay, hold on. 1 question mark is 1 light second divided by that number. Here's the light speed. Times 2 divided by 4.46. See. No, doesn't like that one. Hmm. Let's think about this. So 1 light second over 1. Okay. Multiply by both sides. So 1 something light second. Okay. Maybe. Okay. Okay, Meteor X. Okay, so now it just wants the dimensions. Length is 22.8 meters. Okay. 22.8, 19. 8. 8. Okay. This is in R meters. And they're saying 10.6.1. So, what the hell does that tell us? Or no. Okay, I'm trying to remember. Okay, is that correct? Something feels off about that. I don't know why. Feels off about that. So how do we get this information? What did last transmission tell us? Light seconds. So how do we get to I'm trying to think. Something about the dimensions doesn't seem right to me. I feel like it's off. Hmm. Let me look. What's going on here? Like a set time for like light seconds or space seconds or something? Like space. Of light. Grab the speed of light. What the heck? Mm-hmm. Am I overcomplicating this? Am I overcomplicating this? I had 19. How did I get 3? We need like some sort of conversion ratio. So 19 divided by 10.6, I guess. Point 79. 0.79. Maybe 79 version of like space meters to meters. Okay, and then let's look at 0.8 divided by 2.8 divided by 2.1. 1.8. Are they just both supposed to be 1.8 maybe? 1.8, 1.8. Is that close enough? Is that close enough? Let's see. So 22.8 divided by 1.8. Guess that's like roundish. Say 12. Okay, close enough, I guess. 1.8. Call that space meters? Something? What would you need? We'll say that conversion to meters 1.8. Okay, so we have another new signal. We're back to compounds. Reference chemistry. Compounds? In the water and oxygen. Or no, I'm sorry, this just makes water, right? 2 hydrogen, 1 oxygen. 2 oxygen, oxygen gas. And AN92. The heck is AN92? Uranium. Okay. Okay. Uranium's atomic mass is 238. 238. Compound 1 is oxygen gas is 32. It's 2 oxygen. And then compound something. So what's water's atomic mass? Okay, we know it's 2 and 18. So compound 0 bigger compound 1. Compound 1 bigger. Oh. One less than. Something's off there. Something's off. Test. That thingy area. Well, it's either true or false. Nope. False. Lost on that one. Lost on that one, but I'm sure it'll come clear soon. Proton. Is it mass? I think this must be mass. Yeah, okay. Mass, they're measuring matter. Good, good, good. Great, great, great. Okay. So proton mass. Discontinued. Electron mass. Proton mass. This number times the mass of an electron. Okay. The mass of 2 protons divided by the mass of an electron. Two protons divided by 1 electron. Then P equals E times 8, 3, 6, 5, blah, blah, blah. Okay. So, the mass is 0.0054858. 0.54858. Multiply by 1836152. 13652 73 42302. Okay. So that is the size of 1 proton. Okay. What does that tell us? So we want 2 protons. Want to divide it by the mass of 1 electron. So what is it? 0.05. 0.54858. Round 6 We got there. Okay, greater than or less than. Alright, so clearly they want 1, 2, 3, 4 answers back. The mass of so they just want greater than or less than signs. So an oxygen is greater than a hydrogen. I don't like these transmissions. Why is that? No brute forcing. I think that's the point. The aliens don't want us stranded later. If we happen to get by without understanding, not a fan. Yeah. It makes sense. It makes sense. So helium has a mass of 2. And carbon has a mass of 12. Less than. Okay. One compound of 2 and oxygen. 18. I think the mass is 18 there. Think. Could be wrong. Could be wrong. No, I'm sorry. This is another symbol. I'm being stupid. I mean, we still needed that because that's 18, and then AN7 is 28. This would be less than. We have isotope 2,4. It's an atomic mass of 4. And 19. Less than. Okay, perfect. Signal -68. You know what that means. Gary, will you do the honors? Oh, I don't know. Gary, you got this. Happy dictionary, happy life? Yes. I don't quite understand, but I'm glad it's a bonding point for you two. Come on, Gary, it makes sense. I want all the numbers filled. Alright, so something. Alright, so second equals a time unit. A light second equals a length unit. I feel like this is. Yeah, I think we're correct here. Unit. Subtracting something. Okay. Ooh, something finally piqued your interest? Yes, but no longer. Back to programming. Ah, it was fun while it lasted. Tiny benchmarks comparison. Yeah, okay. We compile. So if a second is a time unit and a light second is a length unit, space meters are length unit. Light second seconds, okay, is a speed unit. Space meters per second is a speed unit. Okay. Other mystery. Something is a mass unit. Variable 8 to the power of 29. Okay, what equals 0? Let's do what equals 0 and see what they say. Okay, you know what? Let me go back one. The unit of mass that is 8/29. The mass of isotope 2656. 2656. Atomic mass of. This combined something. 8/9 whole mackerel times 56. Wow, that's a big number. Okay. Guess if we need it, we're saying this is this. Is a thing that huge? There's something in space with a mass thing. Stars. Dwarf star. Nova. Black hole. No idea. No idea. Okay, so variable 0 is 8 to the power of 29. Compound 0 is 2 isotope 1 and isotope 8. So compound 0 is 2 H1s, 2 1 8. Okay. Compound 0 mass divided by okay, let's see what this is. Let's just find the mass of this first. We already know that 2 hydrogens is a mass of 2. And we know isotope 8 is oxygen. That's got a mass of 16. So this whole thing has a mass of 18. Okay? So isotope 26 the mass of 56. 2 divided by 50. Point. Hold on. Then we want 1, 2, 3, 4. Okay. Compound 0 mass equals 0.3220 something something mass units. Our mystery mass unit. So variable 1 is 2 times 8 to the 29th power. Variable 1 times the mass of compound 0, rounded to 3. Lord have mercy. Okay. Let's do this. 8 to the 29th power. Big ass number. Times 2. Big ass number. Times. 18. Not seem right to me. Something's off here. Something's off. See, something's really off here. Something's really off. I think I don't quite understand these units yet. All these mass units. Go back. Try and decipher what this is. Eight to the 29th power times the mass of isotope 26. Or do they mean abundance? You have to ponder this one. I'll have to think about this one. Maybe we'll pause right here. Let me go think, and I'll return once I have something. All right. I'm back. Take another look at this. Take a little brain break and think. All right, so take a look at what this is telling us, top to bottom. See if we can figure this out. So, let's start with the compound because it's constant. I'll just go back to that. Compound 0 is 2 hydrogens and oxygen. Okay. And we already know that hydrogen is 18, so this is a mass. Compound 0 mass 18. And this second line is saying divide that 18 divided by the mass of isotope 26, 56. So divide by 56. Divide by So, check if that's true. 18. 6. Slide. What I don't quite understand the rounding. Where are they getting this 0.322005395 from? So, let's, I guess, just ignore that for now. Divide the masses, you get this number. This number times this variable gets you whatever this represents in the mass unit. Okay, that's established. Have that established. So, variable 1 equals 2 times 8/29. 8/29 times 2. Copy that, paste that. That's variable 1. Then we're supposed to multiply that by the mass of compound 0. So let's double check the mass of compound 0. Isotope 1,1. Atomic mass 1. Isotope 8/16. Is 16. Okay. That should be 18. 18 times this huge number rounded by 3. Something off. So what else does an isotope specifically give us? If I go to isotope, abundance, would it be abundance instead of mass? Would it be abundance instead of mass? Possibly. Possibly. Okay, let's assume that that's true. Let's assume that that's true. Let's do some math. 0.9976 is the isotope 8/16. That's the abundance. This. Isotope 1 and 1. Abundance is 0.99. 0.99. So, let's go back, do some math. I'll copy this so we need it later. So 0.99 divided by no, I guess we want to add these two. 0.9976 plus 1.9876. 876. So that should be the mass of compound 0. And then we divide this by the mass of isotope. Isotope 2656. Is 0.9172. Okay. But that's not 0.3222, whatever. Isotopes. Let me find the mass of these isotopes, because I feel like that's where we're going wrong a little bit. Okay, here we go. The mass of an atom can be approximated by adding its protons and neutrons. Protons and neutrons both have a mass of roughly 1 Dalton or 1 atomic mass. For example, iron 56, isotope of iron, 30 mass of 55.9493554 Dalton. Okay. Okay, what did that do for us? So add the protons and the neutrons. Chemistry periodic table. So, isotope 1-1 has 0 neutrons, just adding the protons. So this is truly 2. So to get the mass of compound 0, it really is 2 plus isotope 8 and 16. So 16 protons plus 8 neutrons. Okay. Plus 24. So compound 0 is 26, hypothetically. And then we're saying 26 divided by 86. 26 divided by 86. Okay, let's see if that's true. 26 divided by 86. That feels close to something. You can round it, it doesn't quite get there, does it? Let's see what they say. Bleep bloop. What? Did something? No? Huh? Okay then. Okay. Thanks for that. Bleep bloop. Bleep bloop to you too. Back to our previous transmission. Does this help us? Isotope 26 and 56 mass. The mass of an atom can be approximated. Something it's okay. Do we need to add the electrons as well? 1 divided by 1836. So for example, 6 1 divide times 2 plus 2 okay. Because I'm thinking, do we need the electrons of these as well? Oh boy. Okay, let's set a custom variable. 1826. That's what it was. 1826. Mass of atoms. 1836. Okay. 1836. Atomic mass. Okay. Always goes in A regardless of what we do, huh? I don't love that. I just really feel like I'm overthinking this again, but I don't know. Well, let's just say this was our number for the mass of 2 hydrogens. Let's do the mass of the oxygen. Oxygen mass is 16. Plus 8, still the 24. But we need 16 divided by 186. That's what we need, right? Yeah. 16, 1836 divide 24 plus this. Okay, so we have this number, that in there. We have our random other number. Add those together. This should now be the mass of compound 0. Is that true? Is that true? No idea. Let's save that here. Call it water mass. Okay. I want to divide that by the mass of isotope 2656. Ooh, 26. So we're looking for 86 plus 56 divided by 1836. Right? Okay. 56 1836 divide this 86 plus that this. Paste that there. We want our water mass. Divide these together. Still not quite right, is it? Getting this 0.322. Hmm. Okay. Let me put a pause in here. And let me go consult the old Discord, see if I can get a hint on where I'm going. Alright guys, so through some help from the Discord, I think I've got it kind of figured out. So they helped explain the way to think about it is write out what it's asking you in formula form, right? So it's saying variable 1 equals 2 times variable 0. Let's write that. This little section equals variable 1, right? And then we want variable 1 times compound 0 mass equals what? And then they said, well, think about it. You're going to have to convert it to the units of measurement anyway. You're already going to have to multiply by variable 0 on the other side. So, since that's the case, right, now we can simplify. Remove variable 0, remove variable 0. Guess what we're left with? 2 times the mass compound 0. And we already have that here as 0.3222, whatever. So, hypothetically, go here. We go 2 times 0.322005395 times. Copy paste that, round that to 3. Should get 0.644 mass unit, I think. Yep, okay. So, we were definitely overthinking that one a little bit, but it's good to think about that in the future. Is maybe think of it more in the form of a formula rather than trying to get too in the weeds on the numbers. So again, shout out to the Discord. The Discord is very useful. It's got everything separated into acts, and everyone puts everything in spoilers. So you can't, you're not getting yourself spoiled on anything. And a lot of the guys in there are really great about just giving you a hint. They're not giving you the full answer. So again, huge shout out to them. They're a huge help for if you do just get kind of stuck on something that's taking way too long. Because that one I was going way overboard. I started getting into the divide by 1836, stuff like that. So overthinking it a little bit. Okay, so we got another one. So something equals 8 to the power 27 times 1.4831 something mass units. And then this, whatever this something is also a math unit. So I assume this is kind of like, what's it called? Kind of like ounces to pounds or something, right? Like it's just a different way to communicate. Different way to communicate size or mass. Lord, what are we gonna put here? I guess mass units 2. Like a good comparison. Grams. It's gonna be like kilograms. Could just be grams, maybe. It's dirty, and I definitely want to change that once I get their hypotheses on what that could mean, but works for now. So kilograms would be greater than, right? Than a gram. Okay. Or at least our form of it. Mass unit, length unit, time unit is seconds. Okay. Okay, we solved that one. That was a tough week. That was a tough week for sure. And I definitely want to see their hypotheses on that one. I feel like there's got to be better names than what I'm doing. Alright, my favorite part of the week. Meeting with the translation team. Let's switch things up. Dr. Bees, give us the report. No? Alright. Dr. Collins, fill in. We've defined a range of units. And with this, we can communicate measurable information. Measurable information? They've communicated a system of measurements for us. Sounds promising. What kind of units are they defined? Well, we got light second for length, second for time, and gram for mass. See, light second doesn't quite make much sense to me, but that's what my brain came up with. Nothing for energy, temperature, or electricity. Go on. Funnily enough, the aliens defined two redundant units as well. The much smaller space meters for length, the much larger kilograms for mass. Redundancy is unusual. The aliens define new terms sparingly. Over 60 hardly feels sparingly. Redundancy is odd. Any ideas why? I am 1700 millimeters tall. Feeling alright, Dr. Batista? Collins, what's his deal? Unsure, sir. Describing my height in millimeters is horrible, which is why we don't. We use meters or feet. Yep. What's his deal? Dr. Doppler, I still don't... Oh, I understand. They're redundant units. Different units for different scales. I follow, though... Whew, that was a roundabout explanation. You're saying the two units from the aliens might be useful later. Mm-hmm. I'd love to stay longer and ask you more about everything, but apparently humans need to spend a quarter of our lives asleep. Hopefully a third. A fifth is fine. Before I go, I have one more trophy to give. Thank you, Dr. Bees. You may be quiet, but you're the heart and soul of this team. I mean it. I don't think my kid's tennis trophy does it justice, but hopefully it's something to put a smile on your face. So great work, everyone. Let's all get our mandatory sleep. You too, Dr. Doppler. Mm-hmm. Good night. Okay. Okay. Again, another toughie for sure. It's a lot of just overthinking. Wow, look at what we have here. Beautiful space in the mission facility parking lot. Hey, hackers, you clocked out a bit ago. What are you still lingering here for? A lot of stars out tonight. My goodness, you're right. I mean, look at that sky. I wonder where we are. We're probably at like a remote base, alien Area 51 or something. Like, I don't even know. You should head home, get some rest. Gonna need you nice and sharp tomorrow. Yeah. Hackers? Doppler, why'd you want me on the translation team? You're a good astronomer. What's more to say? Plenty of good astronomers. Could have had your pick of the litter. Big names: Sagan, Hawking, Thorne, Drake, Bracknoy. Goodness, I personally know a dozen colleagues smarter than myself. You set your sights on a 34-year-old with a jumpy career. A career that straddled radio astronomy and the Apollo missions. You said, yep, that's the man I need to decipher an alien message. So tell me, Dop, why am I even here? You're a good astronomer, hackers. Come on, take me seriously. I do alright, but I'm nothing next to the giants. And I'll admit, I sit down every day next to Dr. Collins, Dr. Batista, and Dr. Bees, and I see it clear as day. I'm no titan of my field like those three. You're a good astronomer. Quit saying that. Take me seriously. You know what I'm asking, Dop. There's two kinds of good, hackers. There's good in ability and good in character. See, Batista's a good guy, but he's better with computers than he is a person. Hey, now that's not fair. He's a good man. I know he's a good man. Wouldn't have picked him otherwise. But I think the whole world is thankful he turned out to be a moral person. His life could have been a few bad days away from making a supervillain. But instead, we have the quiet, obsessive, sometimes sassy computer genius that he is. So what? I'm no genius, but I've got a good heart. No genius either, hackers. What? I made a long career for myself by being where I'm needed. By working as hard as I possibly can to do for others. When I put this team together, your resume landed on my desk and I made up my mind right then and there. I read your file and saw someone who did what it takes. I saw someone who logged 4,500 hours at the Luchner Observatory down in Berkeley, someone who poured his soul into his PI's research, someone else's research. After that, I saw someone who found a need in the Apollo program, who eagerly did whatever he could to help, to learn, to explore, to work hard for others. And don't sell yourself short. You're a good astronomer. You know your stuff. This team didn't need another genius. It needed someone who'd show up every day and put his best foot forward. It needed you. I get your point. I really do. But I still fail to see how another genius wouldn't have been a better fit. How would another Batista not be better than an Ackers? Alan, you make everyone around you better. Your way of life is contagious. Your zeal for everything makes everyone else want to try as hard as they can, all the time. It's been a while since I've met another academic so comfortable out of their comfort zone. Someone so willing to make mistakes if it meant trying. Now the whole translation team is great. You're all good people. Like I said, wouldn't have picked you for otherwise. I don't think you realize how much you make everyone around you better. You uplift the people in every room you enter. The good things you see in them, a part of that is thanks to you. I appreciate that, Dop. More than you know. Yep. Well, I've got to run home and get at least some sleep. Take care, Alan. Yeah, you too. Astronomer Dr. Alan Ackers decided it was best to gaze at the stars for a while. I mean, what a picture. What a sky, huh? Beautiful. Beautiful. And that was week 19, folks. Week 19. So we had 19 transmissions. We learned 7 words. total of 297 transmissions. We're almost up to 300. We're at a total of 74 words now. Holy cow. And we named light speed, light second, space meters, mass, unit, gram, kilogram, and we completed position calculations, distance units, and mass units. And I'm really hoping they have hypotheses for that, so that we can kind of get better names, because I don't think these names are fantastic, to be honest. I think it'll just confuse us later on. Alan's journal status, thank you. Batista says, I'm 5'7", roughly 1,700 milliliters tall, or 0.94 space meters. Gary's diary. Dear diary, we've spent nearly 300 transmissions with the meteor. We can finally measure time, distance, and mass. Communicating with extraterrestrials is beyond difficult, but beyond worth it. Doppler says, the stars were beautiful tonight. Leave it to the astronomer to point that out. Bees. We're always thinking of bees. Yeah, I would love to read these hypotheses because, like I said, I'm pretty doubtful of what we put in here. Not doubtful in our understanding of what they mean, but doubtful in that I think it's going to confuse us more in the future if we don't change it. So, yeah, fantastic. Let's see if they have anything thing to say. Looks like no. Then I'll see you guys next time. Thanks for watching.